Here I have a problem from the LA City College 2007 math contest that I thought was particularly interesting. It says a game is played where teams gain either 4 or 7 points at a time, and it wants us to find the highest score that cannot be reached. And I thought this was a very interesting problem because I'd never seen something like this before. So let's go ahead and jump into the solution. It's pretty straightforward. So what we want to do is list the possible scores on a chart. So obviously we can't get 0 or 1, but we can get 4. So we can go higher than that, obviously. We can get 7 as well, just by scoring 7. But then we can score 8 points by getting 2 copies of 4. We can then score 11 points by taking 1 copy of 4 and 1 copy of 7. We can score 12 points by taking 3 copies of 4, 14 points from taking 2 copies of 7. We can also score 15 points by taking 2 copies of 4 and a copy of 7. So there's that. We can score 16 points by taking 4 copies of 4. And I just want to point out there's no way to score 9, 10, 13, or 17 points. There is a way to score 18, however. And that's by taking 2 copies of 7, this 14, and adding 4 to it. That'll give us 18. 19, we can take this copy of 12 and add 7 to it. That gives us 19. 20, we can take this copy of 16 and add 4 to it. That gives us 20. And 21, we can take 3 copies of 7. That gives us 21. Surprisingly enough, this is where we can stop and say that 17 right here is our highest unavailable number, or our highest unobtainable score. And we can prove that because what we can do from here on out is take this copy of 18 and add 4 to it to get 22, this copy of 19, add 4 to it to get 23, and so on and so forth. We can always get a number after this just by taking any of these numbers and adding 4 onto it. So 17 is in fact our highest unavailable score. And that's enough for now.